everybody. I'm Vince Marino, and welcome to my Lunch and Learn. I've got a couple of great guests today from Dynamatic, Kevin, Adam, and Gary. And guys, welcome. I want to start off. Let me start with Gary. Gary, why don't you tell us a little bit about yourself, and then toss it to Adam.
Okay. Hey, Vince, thanks for having us. My name is Gary Quain. I'm a sales applications engineer for Drive Source International, and our brand name is Dynamatic. I have been in the industry approximately 40 years, and if I don't know the answer, I'll certainly make one up. Adam?
Good morning. Happy to be here, Vince. Adam Dillon, Industrial Market Manager. I've been with Drive Source International selling Dynamatic brand for 4 years. Love the product and love the opportunity to speak some about it.
Yeah.
Hi, Kevin Haggerty. I'm the business development manager for our municipal market. I've been in the municipal business about 20 years. Had a sales career my whole life. I'm an engineer by degree and enjoy the challenges that come with selling eddy current drives every day.
Well, perfect. So let's start from the beginning. What is Dynamatic? And you mentioned eddy current drives. Why don't you just tell me a little bit about it? I'm just a man on the street, just asking questions. The goal here is someday someone's going to search. They're going to need some kind of a drive. They're going to pop on this video, and hopefully they're going to learn something or several things this year, next year, and on into the future. So that's my passion. Is I want to leave a mark on YouTube by saying, this is information. I want to share it with whoever's interested. So why don't we start with what is Dynamatic and what are the products that we're talking about today? Kevin?
Well, Adam, you're the most long tenured. Why don't you start?
Good deal.
Well, Dynamatic is a brand of variable speed product. We were owned by the Eaton Corporation for about 50 years. So our product was shipped worldwide. And it's used in a number of different industries. Metal forming and stamping is probably our most common. This is on the industrial side. Wire and cable, extrusion, dredging, crane and hoist, and test stand applications are the primary verticals that our product is used in. And we have the ability to manufacture and repair any kind of units that have been in service for 60 plus years. So we support that product, and I think that sets us apart. So that's the industrial side. I can either kick it to Kevin or Gary to kind of cover the municipal side of the business.
Sure.
Yeah, I mean, real quick. So in the municipal business, most of the applications we get involved with are in the pumping world. Regardless if it's a municipal plant or regardless if it's a wastewater plant or a drinking water plant, it's a pretty well-known fact that about at least 70% of the plant's electrical consumption goes towards pumping, be it pumping water or pumping wastewater. And Dynamatic makes a device that's used to control the flow rate or the speed of that pumping. So, like I said, regardless if it's drinking water or wastewater, each of these plants has, at some point during the day, what we call a maximum flow rate, and at some point during the day, a minimum flow rate. And then the flow rate either into or out of the plant varies depending on the time of day that it is. So every plant, of course, if it has a maximum flow rate, all the equipment, the pumps, the motors, the drives, everything has to be sized for that maximum flow rate. But when you come off that maximum flow rate and you start going towards the minimal flow rate, you have to have a way to control the speed of those pumps so that your flow rates go up and go down accordingly to what's required out there in the municipality. So what the eddy current drive does, it effectively slows down the pump, which slows down the flow rate when needed, and it can speed up the pump and speed up the flow rate when needed. So obviously, if most of your power consumption is going towards pumping, if you're not running those pumps at full speed 24 hours a day and you can slow them down when required, you can save energy. And so a lot of the calculations that go into the economics or the return on investment for a drive go into how much power can we save. So, that's where Dynamatic comes into play. That's the equipment we manufacture. And of course, at the end of the day, saving money is the most important aspects in these plants. So if we have an opportunity to allow them to do that, that's why our equipment gets considered.
So, and I want to invite you guys to also do this. I'm going to share my screen. I was just looking at your website, and I'm looking at this right here. If you guys have any other shots or video or anything that you want to share, I encourage you to also feel free to share any visuals. What I'm looking at here, I grabbed this from under the wastewater section. And maybe you could explain what I'm looking at right here, and I'll go back to you guys.
Yeah, so what an eddy current drive is, and that's what you're seeing in that picture there. There's two technologies really in the market that are primarily used to control, like I said, the speed of a pump, or it could be a fan, or it could be a compressor. Whatever the eddy current drive is attached to, it's controlling the rotational speed of that piece of equipment. So in the pumping world, which is our main application, the faster the pump turns, the more flow rate or the more water that gets pumped. And the idea behind the eddy current drive, so what I'm going to say is, so there's two methods. You can either use an eddy current drive, or you can use what's called a VFD, or a variable frequency drive. And the main difference between these two technologies is a VFD is what we consider an electronic form of control. It's typically housed in many electrical control panels that are in a control room in a plant. And the eddy current drive is a rotating piece of equipment, the piece of equipment you saw there. And it actually gets mounted between the motor and the pump, or the component that it's driving. So the eddy current drive is a rotating piece of equipment that becomes part of the pump motor assembly, and it's used to control the speed of the pump. So the main difference is it's a rotating piece of equipment. It's found in the whole assembly of the motor, pump, and drive, where the VFD is an electronic piece of equipment found in a control cabinet off to the side, or in a control room in the plant.
So can you give me an example, or any of you guys jump in here, of a time where I don't know, you were in a particular facility. You don't have to name the name, but you walked in and they were using some other method to run their pumps, and by going in there and doing some investigative sales process, you determine that they need the eddy drive current. As an example, eddy current drive, rather, did I get that right? Eddy current drive.
Correct.
So, I mean, first of all, if you can build the story, what was the client complaining about? Expense, or burning up pumps? Or, I mean, what triggers the need to bring you in to be the expert and to put one of these massive units in a facility?
Well, if I may, I'd like to jump in on this one. I'll give you an example. There's a wastewater treatment plant in the Tennessee area that we do a little bit of business with. They have some pretty large pumps, 700, 800, 900 horsepower, etc. Most of those, when you get above 300 horsepower, most places move to medium voltage, because it's actually a little bit less expensive to use medium voltage to drive motors and pumps and stuff like that. And in the case of this particular plant, they have a VFD. And the VFD, because it is a VFD, it takes AC power, converts it to DC power, and then makes a pseudo AC power that the motor likes downstream. That's does a little bit of stuff electrically to the power distribution system, and it requires that the manufacturer of the VFD, in this case, the manufacturer put a phase shifting transformer in front of the VFD. It's 4160 volts, and the phase shifting transformer, what that does is it actually changes the AC coming into 3 different sets of AC, and that reduces noise on the distribution system. That noise can be a problem. It may be a problem, may not be a problem. It depends on where the plant is what the system feeding it from the utility has associated with it and all that. But those can become a problem in this case because the customer has these phase shifting transformers and they have actually thermal sensors on them, and they're actually tripping in a nuisance fashion. They're not really overheating the transformer, but the sensors are saying they're overheating. So they have to go in and literally take the drive apart, move the transformer out of the way to get in the back of it to the thermal sensor to repair it. Whereas an eddy current, couple of things, it doesn't care electrically what the utility has. We don't produce noise back onto the line. At the same time, we don't need phase shifting transformers and things like that. As Kevin told you, it's more of a mechanical solution, but it's also electrical too. It's electromechanical, if you will. And in that, the controller literally is in parallel to the drive itself. Kevin told you that the drive is downstream from the motor, but before the pump or the fan or whatever being driven, and that is correct. So the beauty of that is that you don't draw as much power in doing the control of the unit. Also, you don't produce the noise coming in, but also the noise going out. The advantages are tremendous. So when you walk in and you see that the customers are having problems, typically maintenance problems, and that manifests itself into having to get a technician in there that's trained and qualified to work at the medium voltage level. Whereas you take a look at the eddy current drive, they can be maintained by any technician in a plant that has a grease gun and a screwdriver. And they can call our services line if they want a tutorial on maintaining brushes and coils and that sort of stuff. So those are some of the highlights. Gavin, do you have any more?
Yeah, no, I mean, I think to maybe just summarize what you just said, in a lot of plants we go into. So the one thing that's known about an eddy current drive and a VFD, the eddy current drive technology was developed back in the 30s and 40s, and it was very popular through, say, the end of the century. VFDs came on the market in the 80s, and people started putting VFDs in there based on a lot of promises about better efficiency, easier to maintain, easier to operate than an ECD or an eddy current drive. And we've sort of run that life cycle a little bit. And what we a lot of times walk into is a plant where they had eddy current drive technology, and that eddy current drive technology typically would last 30 to 40 years in a plant if operated and maintained properly. The VFD technology, on the other hand, typically only lasts about 10 to 12 years in a plant. So what we have in a lot of cases where we go into these older plants, and the average life the average year that a wastewater plant's been in operation in the United States exceeds 50 years on average. So a lot of the plants we walk into are 50 plus years old in terms of equipment. And so we have plants where they had eddy current drives. They switched to what they perceived as a better technology, which was the VFD. And now they've gone through that life cycle. And what they realized is the VFD's lifetime typically is about 1/3 that of an eddy current drive. So the eddy current drive lasted 30 years, the VFD lasted 10. And it's not uncommon for us to have a plant manager tell us, I'd like to go back to the eddy current drive because I don't want to replace this VFD 2 or 3 times in the lifetime of the equipment I had prior to it. So, a lot of the things that have evolved that were supposed to be a better mousetrap have maybe turned out not to be the better mousetrap. And a lot of the older plants are going back to the older technology, or what we call the proven technology.
Wow, I like that. Sometimes old technology is, if it works, it's substantial, and just leave well enough alone.
Yeah, I mean, it's easy to make a lot of promises on something that hasn't been trued and tried yet, right? So it's often, like I said, the case where a plant manager say, I had that, I like that, I tried this, I didn't like that. So I want to go back to what I think is a little bit more reliable. And like Gary said, the eddy current drive is a pretty basic device when it comes down to comparing it to a VFD. And the other real advantage we have in the plants is the plant personnel can maintain and repair an eddy current drive where the VFD technology is much more complicated, and the normal plant personnel is just not trained to repair that type of equipment when it goes down. So
Yeah,
they end up waiting for a technician to board a plane, get to the plant, and hopefully be able to repair it while he's on site. A lot of times it might be, we have to order parts, we have to wait for parts, and that VFD gets bypassed in the meantime.
yeah, I get
Yep.
the impression that it's kind of like what happened with the auto industry, where you raise the hood of your car in recent years, and you need to be an electrician to work under the hood. And back when we were all younger, you had a straight 6-cylinder engine, which was pretty straightforward. You could work it in your garage.
Yep, absolutely.
And I'm not trying to minimize the Dynamatic product. Obviously, it's got some real benefits. I'm assuming also some dollar for dollar benefits too. I mean, if it's going to stay in there for 30 years.
Well, yeah, I mean, there's a lot of cases where either we can do this cost evaluation for a client, or they can hire a consulting engineer to do it. But when the customer realizes that they're going to have to buy 2, perhaps 3 VFDs to get to cover the lifespan of one eddy current drive, you really have to take those costs into effect. And it's not just the cost of the equipment itself, it's the cost to have a contractor come in, remove the old equipment, install the new equipment, and all that really adds to the overall cost of a replacement. And when they know they have to replace it 2 or 3 times in the lifetime of one other piece of technology, the eddy current drive almost hands down comes out ahead when you do a 20 or 30-year life cycle comparison between the 2 technologies.
I'd like to jump in, Vince, if I could.
Sure.
The other advantage that we're kind of talking about here, as well as the fact that we support our units going back to like the 50s and 60s with OEM replacement parts. You're not going to get that kind of support for VFDs. I mean, they get obsoleted after 5 to 7 years, and then you have to buy a new one. So the fact that we support our product is a massive advantage. And on the industrial side, I see that every day. I have a number of extrusion customers down in Texas that have used our product for 60 years, our liquid cooled couplings, and we repair those to OEM spec on a regular basis. And the other advantage of eddy current drives is that our product can be used outdoors without any kind of climate control or any kind of accommodations that VFDs, being electronic equipment, would need. So that sets us apart as well.
Wow. You got any, if you guys have any photos to share, please feel free to jump in and share. Gary, you're going to say something?
Well, to Adam's point there about the product being rugged, it's very true. In fact, what the eddy current does is it takes what the input comes in from the motor and it transmits it to the load, and it varies the speed by changing the amount of magnetic coupling between the incoming motor shaft and the outgoing power. The beauty of it is, and the thing that's always impressed me about the eddy current drive, is that it can literally produce whatever torque the motor puts into it. If the motor is loaded very heavily and it gets above its standard rating and goes toward two characteristic areas of importance are the pull-up torque on the motor and also the breakdown torque. The eddy current drive can transmit that, and that's typically in the range of about 250% of rated torque. Now, in the industrial applications, that's extremely important. In the municipal world with centrifugal pumps, it's not that big of a deal, but there are applications in pumping that are important where you need that extra torque, and that's anytime that you're using a positive displacement pump, a rotary load pump, or a progressive cavity pump. You need that torque. The VFDs just can't do it. You have to oversize them by a factor of 1.75 to be able to get there. And then it's also rough on them because it draws excessive current to produce that on the motor.
Interesting. Thank you for sharing that. Well, I'm impressed. I was looking at, like I said, I was kind of perusing the website. I'm going to go back to it for a second. And Adam, where can we find industries that you're dealing with? You said extrusion.
Yeah, so metal forming and stamping, that's probably our largest vertical market. So our product is used on by the big three automotive companies, other auto manufacturers, and some of the tier one, tier two suppliers to the automotive manufacturers. So it can vary from, a 5 or 10 horsepower unit all the way up to one of our largest, what we call our CES, constant energy system, clutch brake units that are used on like 1,700-ton Version and Danley presses. So a lot of those units have been in use since the 1970s. And they're still, we refurbish those on a regular basis. I do have a picture of one of our CES units if I could share it.
Absolutely. Just click that share screen. And when you see your picture in the pop-up, just click on it.
Okay, and then
Oh, wow.
so this is one of our CES 4942 units that's used. This is actually from one of our stamping customers in Mexico that sent to us for refurbishment. So the 49 is the belt ring size, 49 inches, and then the 42 means there are 4 clutch coils and 2 brake coils. Now these are on the end, on the left end, you can see there's a coupling half there. This unit tends to be either direct coupled or belt driven by a motor, and it's either mounted on top of a stamping press or on the floor next to it. And this particular unit is somewhere around 25,000 to 30,000 pounds. So it's the second largest CES unit that we make. So this product is like I said, it's used by the big three, and it's used by a lot of the tier one and tier two suppliers that manufacture parts, stamp parts for automotive applications. So just wanted to share that
No,
share
that's
that visual.
massive,
Yeah.
massive. Now, did they have to send that whole unit back to get it repaired, or did?
Yeah, so they have to, so there's some rigging involved. They have to get it, if it's on top of the press, they have to get it down off the press, put it on a flatbed, they send it to us. We do a full tear down evaluation and we restore it to original OEM standards, and we do a run test on it before we ship it back to make sure everything is copacetic. We also do manufacture, sell, and repair the electronic controllers that are used with these units. And the larger the unit, kind of the more complex the control is. But we have some projects in place now with some stamping customers to replace the older version of the CES with their newer CES EC2000 stamping press controller. So there's definitely a lot of demand for our product out there. And like I said, it lasts a long time. The vast majority of these CES units were manufactured in the 70s and 80s. And originally sold to Danley and Version put on presses, and they're pretty much timeless. I mean, we can repair them, and they have a really long lifespan. They generate a lot of money for the companies that use them, and it's one of our best product lines for sure.
What's the turnaround time from discovering, they have to do some kind of maintenance to getting it back in action? What kind of a timeline does it take?
Yeah, so it depends on the scope of repair. So if it's something that we have to manufacture parts for, like a rotor or some of the coils or some of the other kind of longer lead items, I mean, it could be like 12 to 14 weeks. A lot of these customers have the foresight to have spare units on hand, so they'll pull the one off that needs service, they'll put on the spare, and they send us the one for repair. But we have done some quick turn repairs in the span of a couple weeks. So we typically try to do a full teardown evaluation and the whole 9 yards. Sometimes we're not able to do that, so we just diagnose what needs to be repaired and get it done quickly. So kind of depends whether or not the customer has a spare unit and how much time we have as to how we respond and service them.
Still, that's even 12, 14 weeks is still quite impressive. And everything's made at your shop, at your facility.
Yeah, the bulk of it is. We do have some partners we work with, but a lot of the work is done at our facility in Sturtevant, and everything is done to original Dynamatic spec. We still have all the drawings going back to the 1950s for all the components and whatnot. So we're able to exclusively offer that level of service.
I really love that. It's almost nostalgic, you know. I mean, you've got this product that I have new respect. I'm really learning more about what this is all about. You know, I've known Mike over there for quite some time, and we've talked about Dynamatic, but you know, to hear you guys talk about a couple of field challenges and showing some pictures, it actually gets me a little bit closer to understanding exactly what you bring to the table. And it looks like for those that have the equipment, they really must really appreciate the relationship and your capabilities.
Yeah, absolutely. We have a number of Fortune 100 customers that that use our product and have used it for decades. And being able to offer not only the operational, mechanical, electrical support, but also the engineering expertise to help them solve problems that come up that may or may not be related to our product. It may be related to water flow or something like that. That's really a value add that we're able to do that a lot of other companies aren't able to necessarily have that level of expertise and have that kind of close-knit relationship.
I love it. Let me ask you guys, just for everybody here, are there instances where somebody's building a brand new factory, right? And because of their historical knowledge of the Dynamatic products, they want a brand new unit installed in their new factory?
Yes. Yes.
Yeah, I think that's absolutely the case. I mean, we have some rather large projects for our company being delivered this year and next. One of them's in the state of New York. It's six 600 horsepower drives and motors that are going on new pump applications that we're delivering. There's another one in northern New Jersey that's 500 horsepower pumps and drives going on new pumps and a new one's a wastewater plant and one's a pumping station. And a lot of those applications, well, those applications specifically came from the consulting engineer's advice to the city to install this equipment because, you know, like ourselves, he's more senior. He's been around this equipment for many, many, many years. And he just felt because of the reliability, the size of the installation, where it's going in terms of a very populous city, and the reliability that it's been shown to show, that it was the best technology for the application. So a lot of times, even the new installations we got are because either the plant personnel or the engineering personnel, someone in the decision-making process had knowledge of eddy current drives from a past plant or a past application and felt it was the best technology to be used. Even though there's supposedly newer, better technology on the market, they just looked at these applications and said, these are too big, these are too important to put something in that may not live up to the what we expect, or may fail prematurely, or may be too difficult to work on, you know, whatever the reasons. But in many of these newer applications, it's because of experience they had from many, many years ago that they recommended it.
Wow, that's amazing. So in a way, even a consultant that would be wanting to know a little bit more about your product could surf on and hear this and possibly add that to his list of items, his wisdom, if you will, and share it with upcoming clients. So that's a good thing.
Absolutely, and it goes without saying that a lot of the lunch and learns we'll do at an engineering firm. I can think of one specifically where I've done one recently, and there was a room full of, 10 or 12 young engineers out of college in the last 5 years. And a lot of times I start my presentation by asking how many people know what an eddy current drive is and have a show of hands. And not a single one of the young engineers knew what it was. And one of the reasons for that is because they don't teach it in college anymore. And normally it's the, I hate to say gray hair fellow, but the older fellow in the back of the room who at least raises his hand and says, I know what it is.
Yeah.
Because it was a technology developed, long enough ago that it's almost a forgotten piece of equipment that if we could encourage people in the engineering community and even the plant world to learn more about it, they may find that, Dynamatic actually has a better mousetrap, even though a bit older than the newer one,
I love it.
Well,
Gary,
the beauty
guys,
is it doesn't come from, it doesn't have some of the problems that you have with the newer technology. You don't have to worry about buying equipment to fix noise issues with respect to power coming in or power going out. You can transmit a whole bunch of torque that you have to oversize or pay more money for with other technologies. And if you take a look at some serious pumping applications, take the Permian Basin in Texas and New Mexico where they're fracking down there, and those are high pressure pumps that they're using. Those people are going out and they're spending $500,000 to $700,000 to put filtering in front of the electronics. Because when you get out to the Permian Basin, most of the loading out there electrically is these units. It's not so much the commercial office space or the residential space or any of that. It's literally these people doing the fracking. And our technology would fit right in there with no fuss, no muss, and you eliminate those problems with one investment instead of multiple investments.
Gary, you brought up sound or noise more than once. So I am curious, what kind of noise does your competition emit? Is it just traumatizing to the ear, like nails on a chalkboard, or?
Well, most of it's electrical events. When I talked about input noise, basically you're taking in a variable frequency drive, you're taking alternating current, you're converting it to DC current. That makes the device nonlinear. And what that does is it chops up the power on the input. Other devices don't like it. The power companies don't like it, and they charge you for it.
Oh,
Then there's literally audible noise because the VFDs, as I said, they take AC, make DC, and then make a pseudo AC. And when they make that pseudo AC, the motors actually hum. So they drive up the frequency of the pulses that they send to the motor. And what that does is it takes the hum higher and higher and higher, and it takes it out of your hearing range. But that's not good for the motor. It causes the motor to heat up more, to have greater losses and stuff like that. But also those higher frequencies for switching are transmitted on the motor cables and actually get into the radio frequency band, which causes a host of other problems, especially say with a wet well application where you're maintaining level. You have a sensor there, an ultrasonic sensor typically, sometimes they're resistive, but basically a sensor. And that radiated noise can cause those sensors to act squirrely and send erroneous information back to the control systems. But also it can cause a host of other problems with respect to what's being transmitted in the air, and it's referred to as RFI/EMI, and you have to be very, very careful of it. VFD manufacturers recommend that contractors use VFD rated cable between the VFDs and the motors, especially for long motor runs that are in excess of 100 feet. That adds cost. And also it requires contractors doing the installation to follow good wiring practices and things like that. It doesn't sound like a lot, but as you get into it and the problems manifest themselves, it all goes back to just basic principles of electrical engineering.
If I could jump in, Vince, I just wanted to kind of highlight the difference, between VFDs and eddy current. So the way the VFD works, it ends up burning out the motor windings relatively quickly compared to our unit. So we often get in eddy current clutch and motor assemblies that have been on stamping presses for a couple of decades. The way our unit works is the eddy current clutch is actually the piece of equipment that does the variation in speed, whereas the motor just runs at a constant speed. And it's not uncommon for us to get one of these units in that's been in operation for 20, 30 years and not have to touch the motor at all, because there's no load on it. Essentially, it just runs at a constant speed. The clutch is actually what we end up having to service, but that's another advantage of our product, where we don't burn out the motor. It actually lasts for decades because it's just there's the way it works is there's not really a lot of load on it. So
Right, but
there's something
the whole intention of a clutch is to sacrifice the clutch as opposed to the motor. I mean, in my opinion, that's the part that if something's going to need to be repaired, that would be it. It's kind of like the like brake shoes, right? I mean, you're admitting that there's going to be wear at this point, but I totally get that. But to fully understand that it doesn't wear the motor down at all is just remarkable. You know, you got you win. You guys win.
Well, the beauty of the drives themselves, or the clutches, your choice on names, is that we designed these for a lifetime, Vince. The bearings we have on them are rated, we call it L10, or 100,000 hours. They're meant to last as long as the process is there, especially when we get into municipal pumping. When they put in pumps that last 40, 50, 60 years, our drives are meant to last as long as those pumps last, because these are really big pieces of equipment, and to disassemble them, to take them out, to change a bearing is a bit of a job.
Fantastic. Well, you're not going to believe this, but we have literally been chatting for about 45 minutes or so. Goes by fast, doesn't it?
Time flies.
Yeah. Well, let me just wrap up with asking you guys a couple of things. Kind of like 20 questions, but I'm going to keep it limited. But what do you guys do for fun? Kevin, what do you do on your off time? What do you do for fun?
Well, I'm an avid golfer when I can get out. I have 4 children that are out of the house, and now they're getting married and having babies. So I have at least 1 grandchild to take care of, and looking forward to number 2 and number 3. But, you know, it's, for me, all through my career, it's always been about the family. I mean, once we started having kids, you know, you take care of them when they're little, middle-aged, and now that they're adults, you try and help them out as much as you can as well then. So.
You know, I have to honestly, I do this fairly often, and I hear that's been the overriding comment. Now, you know, somebody might like fishing or golf, but everybody that does this seems to circle back to it's all about family. I love that. Gary, what about you?
It's pretty much the same. I golf. We also, my wife and I, we travel. We're empty nesters as well. No grandkids yet. Of course, I'm not as ancient as Kevin. We like to go to England and Italy. My wife is actually Italian. This year we're going to go to Korea. So it's a bunch of fun. We travel, and that's what we do with our spare time.
Beautiful. Adam?
Yeah, so I'll echo my colleague's sentiments. So yeah, family's definitely first and foremost. I have an 11-year-old daughter, and she's a dual sport athlete, so she's really big into basketball, and track season is starting. So it's just a lot of our time, my wife and I spend getting her to training sessions. She trains actually 6 days a week for basketball. So that takes up a lot of our time. And then we're a pet friendly family. We have a 85-pound golden doodle rugby, and then we have 4 cats. So between the daughter and the pets, they keep us pretty busy. So.
Oh man, I can imagine. Well, I got to tell you, I have learned a lot, both about you guys and about Dynamatic, and I got to say I'm impressed. And I do hope that this little package of information is going to help somebody someday. Tell me, if I was some consultant and I needed to get a hold of you guys, what's the quickest, fastest way to touch base with the folks at Dynamatic?
Well, Dynamatic has an 800 number. We have a website. We have a contact us, link on our website. And of course, all of us, are out there in the field. If we haven't met you yet, we hope to meet you in the future. And if you have a business card and a phone number, we all carry cell phones. You can basically reach us 24/7. That's the kind of world we live in. So
Great.
I'll throw the 800 number out there, 800-548-2169, or sales@dynamatic.com.
we go.
Perfect. Well, I'll make sure we get that in the information below on the actual video. And I can't thank you guys enough. It was great meeting you all.